In this video, I will show you how to find intervals of increasing and decreasing given the equation of the original function. If you appreciate the content, please give it a like. On this chart, I have summarized the graphical relationships between f, f prime, and f double prime. Make sure you have memorized these. You should be able to draw this chart within 30 seconds in the margin of your next test or on a piece of scratch paper. This chart can help us find where a function f is increasing or decreasing. For example, if f prime at a is positive, then f of x is increasing at x equals a. If f prime at a is negative, then f of x is decreasing at x equals a. And if f prime at a is 0, then f has a horizontal tangent line at x equals a. You can't actually abbreviate like this. You have to write it out. Horizontal tangent line. This year, a friend of mine is an AP grader, and she's telling me that some of the AP graders aren't accepting any abbreviations at all. So, if I were you, I would not use any of these abbreviations. Just write out the words increasing, decreasing, concave up, concave down, positive, negative, 0, all that. Also, if f prime at a is undefined, there are a few things that might have been going on the original function f of x at x equals a. In a word, if f prime at a is undefined, then f of x is discontinuous at x equals a. If f of x is discontinuous at x equals a, the discontinuity could be a hole, a jump, or an asymptote. But there are other reasons why f prime at a might be undefined. For example, f prime at a is undefined if f of x has a corner or a cusp at x equals a. But there's one more. F prime at a will also be undefined if f of x has a vertical tangent line. So these are all the features of f that would cause f prime to be undefined. If you are given the graph of f of x, it's easy to identify the intervals on which f of x is increasing or decreasing. For example, we can see that f of x is rising from here to here. That's the interval from negative infinity to negative 4. Then we can see that f of x is falling or decreasing all the way down to here. Notice that I used a parenthesis, not a bracket, on the negative 4. That's because as we approach negative 4 from the left, f of x is increasing. After negative 4, f of x is decreasing. But right at negative 4, f of x is neither increasing nor decreasing. It's a horizontal tangent line. So negative 4 should not be included in the increasing interval. And we show that with a parenthesis. Basically, whenever you are doing intervals of increasing and decreasing, just don't use square brackets. Always use parentheses everywhere. F continues to be decreasing on this interval because there is a discontinuity here. Write this as two separate intervals. Don't try to say that f of x is decreasing from negative 4 to infinity. There's a jump here, so go ahead and make a second interval for the interval from 1 to infinity. What we call the critical numbers of f are often the key to finding many things in calculus. The critical numbers of f are where f prime is equal to 0 or where f prime is undefined. Notice the jump in level. If we are talking about the critical numbers of f, we are talking about where f prime is equal to 0 or undefined. If you are given the graph of f of x, you should be able to easily identify the critical numbers of f. Remember, the critical numbers of f are where f prime equals 0 and where f prime is undefined. But we're looking at the graph of f, not the graph of f prime. So how do we know where f prime is equal to 0? Remember, f prime is the slope of f. So the slope of f will be 0 at any horizontal tangent lines. So f prime will equal 0 at x equals -4 and at x equals -1. These are the first two critical numbers of f. How many places on this graph of f do you see where f prime will be undefined? F prime will be undefined at x equals 1 because f of x has a discontinuity at x equals 1. But f prime will also be undefined at x equals 2 because f has a corner at x equals 2. So these are the four critical numbers of f. But how do you identify intervals of increasing and decreasing if you're not given a graph and you're only given an equation? Before we get to that, let me show you how to write your justification for why f of x is increasing or decreasing. We know that f is increasing wherever f prime is positive. So our justification for an increasing interval is f of x is increasing on the interval from a to b because f prime of x is positive. Of course, on a real problem, it won't be a to b, it'll be numbers like 2 to 5. Similarly, to justify a decreasing interval, we will say f of x is decreasing on the interval from a to b because f prime of x is negative. The big idea is that the sign of f prime tells you whether f of x is increasing or decreasing. There are three steps for finding the intervals of increasing and decreasing given the equation for f of x. Step 1 is to find f prime of x. Step 2 is to find the critical values of f. Remember, the critical values of f are where f prime is equal to 0 or where f prime is undefined. Step 3 is to use the critical values to make an f prime sign chart. Then we will know that f is increasing wherever f prime is positive and f is decreasing wherever f prime is negative. Let's find the intervals on which the graph of y is increasing and the intervals on which it is decreasing. Step 1 is to find y prime. Using the power rule, the derivative of the first term is -4x to the third power. The derivative of the next term is -12x squared. The derivative of the third term is 40x, and the derivative of a constant is 0. The next step is to find the critical values of y. That's where y prime is equal to 0 or where y prime is undefined. In order to find that, it will be easier if we rewrite y prime in factored form. I'm noticing that every factor has an x in it, and every coefficient is divisible by 4. I always like to bring out the negative whenever there is a negative leading coefficient, so let's factor out a GCF of -4x. On the inside of the parentheses, dividing each term by -4x, we're going to get a positive x squared, a positive 3x, and a -10. This trinomial looks like the type of thing that would be factorable. So let's give that a shot. Let's try to factor this as a binomial times a binomial. X squared can only factor as x times x. 10 can factor as 1 times 10, but it's probably going to be 2 times 5. Inner plus outer must equal the middle of 3x. We can make a positive 3x if the outer is positive 5x and the inner is -2x. Also, -2 times positive 5 makes -10. So we have now factored it. Y prime is a polynomial, and polynomials are defined everywhere. So the critical values of y will only be where y prime is equal to 0. We can find the values where y prime is equal to 0 by setting each factor equal to 0. Setting this first factor equal to 0, we get x equals 0. Setting x minus 2 equal to 0, we we get x equals 2. And setting x plus 5 equal to 0 gives us x equals negative 5. So these are the three critical values of y. You build a y prime sign chart by making a row for each factor of y prime and putting the critical numbers in order from least to greatest across the top. We need to decide whether each factor is positive or negative in each one of these intervals. Let's start with the factor of negative 4x. Your work will go faster if you identify the critical value that came from the factor you are analyzing. In other words, negative 4x is equal to 0 at x equals 0. So I'm going to put an extra highlight right here. This is the only place where this factor might change signs. In particular, negative 4x is going to be positive to the left of 0. Think about it. To the left of 0, these are negative numbers. Like for example, in this interval right here, we would have negative 1, negative 2, negative 3, negative 4. If you plug a negative number in for x, you have a negative times a negative, which is a positive. So this factor will be positive to the left of 0, and it will be negative to the right of 0. Think about it. If you plug in any positive number, you're going to have a negative 4 times a positive number. That's going to be a negative number. Similarly, the factor of x minus 2 is equal to 0 at x equals 2. This factor will be negative to the left of 2 and positive to the right. The factor of x plus 5 is equal to 0 at x equals negative 5. This factor will be negative to the left of negative 5 and positive to the right of negative 5. The overall sign of y prime will be recorded across the top. It depends on the number of negatives in each column. If you have an even number of negatives, that's a negative times a negative, which is a positive. If you have an odd number of negatives, the overall sign is negative. So y prime will be positive on the interval from 0 to 2 and negative from 2 to infinity. The original function y will be increasing wherever y prime is positive. That's on the interval from negative infinity to negative 5 and the interval from 0 to 2. We say y is increasing on the interval from negative infinity to negative 5 and on the interval from 0 to 2 because y prime is greater than 0, or you could say because y prime is positive. Similarly, y will be decreasing wherever y prime is negative. That's on the interval from negative 5 to 0 and the interval from 2 to infinity. We say y is decreasing on the interval from negative 5 to 0 and on the interval from 2 to infinity because y prime is less than 0, or because y prime is negative. On previous videos that I've made over the years, I have been using a lot of abbreviation. So for example, I would write I and C for increasing, and I would write DEC for decreasing, and I would write B/C for because. I'm used to using abbreviations all over the place. However, my friend is an AP grader this year, and she's warning me that it's basically up to the grader if they want to accept your abbreviation. And some graders are out there marking problems wrong if you put INC or DEC or B/C for because. So going forward in my videos, I'm not going to be using abbreviations, and I recommend that you don't use abbreviations either. Just be safe. Because of the periodic nature of trig functions, when they ask you to find the intervals of increasing or decreasing, they almost always give you a limited domain. So watch out for that. The first step is to find f prime. The derivative of a constant is 0, so that's gone. The derivative of 4x is 4. When we see a constant in the front, we just bring that down, and then we move on and take the derivative of whatever comes next. This is a memorized rule. The derivative of tangent x is secant squared x. So this is f prime. The next step is to find the critical numbers of f. which is where f prime is equal to 0 or where f prime is undefined. Let's start with f prime equals 0. So setting this equal to 0, we have 4 minus 3 secant squared x is equal to 0. Adding 3 secant squared x to both sides, we get 4 is equal to 3 secant squared x. Dividing both sides by 3, we get 4 over 3 is equal to secant squared x. I'm just going to flip this around. Taking the square root of both sides to get rid of this exponent, we will have secant x is equal to plus or minus. Don't forget, when you take the square root of both sides, the solution can be positive or negative. And now I'm taking the square root of 4/3. When you take the square root of a fraction, you take the square root of the numerator and the denominator separately. The square root of 4 is 2, and then in the denominator we have the square root of 3. Now I'm going to take the reciprocal of both sides of this equation. Secant is the reciprocal of cosine, and cosine is the reciprocal of secant. So the reciprocal of the left side is cosine x. Obviously, the reciprocal of this side is radical 3 over 2. Hopefully you memorized these 9 trig facts long ago. So ignoring the plus or minus, you can ask yourself the cosine of which angle is radical 3 over 2. And of course we know that the cosine of pi over 6 is radical 3 over 2. That means pi over 6 is the reference angle. A reference angle is the angle between the terminal side of an angle and the x-axis. Every quadrant has an angle with a reference angle of pi over 6. However, in this case, we are restricted to the domain of 0 to pi. So we will disregard these two potential solutions. Cosine is allowed to be positive or negative in this case, so both of these angles are solutions. The angle in the first quadrant is the reference angle itself, so that's pi over 6. What about this angle right here? We can think of pi as 6 pi over 6. So this angle right here is pi over 6 less. That's 5 pi over 6. So these are the two solutions, and those are two critical values. X equals pi over 6 and x equals 5 pi over 6. The other source of critical numbers is where f prime is undefined, and f prime will be undefined wherever secant x itself is undefined. But secant x is 1 over cosine x, and this expression will be undefined wherever the denominator, cosine x, is equal to 0. So really all of this we do in our heads. This is the part we actually write down. Where is f prime undefined? Wherever cosine x is equal to 0. Cosine is the x value on the unit circle, and x values are equal to 0 here and here. Since the domain is limited to the interval from 0 to pi, we will disregard that second one. So the other critical value is x equals pi over 2. Now it's time to make the f prime sign chart using our 3 critical values in order from least to greatest across the top. Make sure you label the sign chart as the f prime sign chart. This is part of your work. And make sure you include the endpoints of the domain, your 0 and your pi, which are not included in the solution. We need to determine whether f prime is positive or negative in each interval. We're going to pick a test value from each interval and plug it in to see whether f prime is positive or negative. In this first interval, we are actually allowed to use the 0 as a test value. So f prime at 0 would be 4 minus 3 secant squared 0. But remember, secant is the reciprocal of cosine. So what is the cosine of 0? Cosine is the x value on the unit circle, and here at the starting position of 0, the x value is 1. So cosine is 1, and secant is the reciprocal of that. The reciprocal of 1 is still 1, and 1 squared is 1. So basically, secant squared 0 is 1. So we are left with 4 minus 3, which is positive. So f prime is positive in the first interval. In the next interval, we need to pick a test value between pi over 6 and pi over 2. Well, pi over 4 falls right here between pi over 6 and pi over 2. So let's use pi over 4 as the test value. We need to find the value of secant squared pi over 4. Let's start with cosine. We know that the cosine of pi over 4 is radical 2 over 2, or 1 over radical 2. That's the same thing. I'm going to choose this way because we are going to want to take the reciprocal in a minute. Because the secant of pi over 4 is the reciprocal of cosine. And the reciprocal of 1 over radical 2 is a nice clean radical 2. What we really have is secant squared. So secant squared pi over 4 will be radical 2 squared, which is just 2. So we have 4 minus 3 times 2. That's 4 minus 6, which is negative. So f prime is negative on the second interval. Next, we need a test value between pi over 2 and 5 pi over 6. We can think of pi as 4 pi over 4. So this angle right here must be 3 pi over 4. And that's right in between pi over 2 and 5 pi over 6. So let's use 3 pi over 4 as our test value. Let's start with the cosine of 3 pi over 4. Since the reference angle is pi over 4, we know the cosine is still going to involve 1 over radical 2. However, in the second quadrant, cosine, which is an x value, is negative. So the cosine of 3 pi over 4 is negative 1 over radical 2. So secant of 3 pi over 4 will be the reciprocal of this, so negative radical 2. However, when we square this, the negative is going to go away. So we're going to get a positive 2 again, just like we did last time. So that means the result will be the same. 4 minus 6 is negative. So f prime is negative on the third interval. For the final interval, we can use pi. Let's start with the cosine of pi. Pi is right here. Cosine is the x value on the unit circle, and the x value is negative 1. So the cosine of pi is negative 1. The secant of pi is the reciprocal of this, which is still negative 1. But what we really have is secant squared. And when we square this, of course, we get positive 1. So what we have is 4 minus 3, which is positive. So f prime is positive on the final interval. Remember, our goal is to say where f is increasing and decreasing. We know that wherever f prime is positive, f will be increasing. That's from 0 to pi over 6 and 5 pi over 6 to pi. And wherever f prime is negative, f will be decreasing. That's going to have to be two separate intervals. We're not allowed to say from pi over 6 to 5 pi over 6 because right here at pi over 2, f prime is equal to 0, not negative. So we begin by saying f of x is increasing on the interval from 0 to pi over 6 and on the interval from 5 pi over 6 to pi because f prime of x is positive. And we say f of x is decreasing on the interval from pi over 6 to pi over 2 and pi over 2 to 5 pi over 6 because f prime of x is negative. Again, you cannot write this as one big interval from pi over 6 to 5 pi over 6 because right at pi over 2, f prime is undefined. It is not negative. So that's it. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.